All right, today we are talking about laws of exponents, also known as exponent rules. We have already done several of these up to this point, so a lot of this is going to feel like review, which is good. And actually, all of this, to some extent, is review, because if we haven't discussed it in this class yet, you did learn it back in Algebra 1. The only difference is this is going to involve fractions. That's what the calculators are for. I do want to talk about the calculators for just a moment. Most of you have one of two calculators in here. These are the only two I have that I'm able to show you how to do the math with. So if you have a different calculator and you're unable to figure out how to use it based on my instructions, please wait until after the notes to ask these questions. I'm not very helpful from here to see your calculator and instruct you further. So just want to give that heads up. Personally, I prefer the white calculator for these problems specifically. They are just a tad easier to use, but both calculators work about the same. All right. First off, 5 squared. I hope you are well aware of the terms here. The 5 is referred to as the base, and the 2 is referred to as the exponent. All right, let's go over some rules. Number 1, 4a to the 2 sevenths times a to the 4 sevenths. First off, there's a 1 in front of that a, so when I multiply the 4, I'm multiplying it by that 1. And it'll just carry over into my answer as a 4. And then for the a's, when I multiply the a's together, what do I do with the exponents? Thank you. Add them. We've already done that a couple times in some of the notes. So we have 2 sevenths plus 4 sevenths. Since these fractions have the same denominator, this is considered a pretty easy fraction problem, so I'm not going to use the calculator, but if you would still feel the need to, you absolutely could use the calculator on this. 4a to the, when you add, you just add across the top, 6 sevenths. And that's it, that's our answer. Now remember, these are notes, so I am going to write down why I was able to do what I just did. When you multiply the same basis, add the exponents. And when I say the same basis, I'm just referring to the two a's term being the same. Number 2, here's our next rule. Again, we've actually already used this one. X to the 2/3 over x to the 1/6. What do I do with the exponents? Before that, like what operation am I going to do here? Subtract. Yes. 2/3 minus 1/6. These fractions have different denominators. This would be considered a not so easy fraction type problem. This is where the calculators come into play. I'm not in the business of reteaching, adding, subtracting, multiplying, dividing fractions. I'm just going to get through it, so the calculator can do the work for us. I'll start with the white calculator. And you could try to follow along on the other type if that's what you have, because the buttons pretty much are the same. So first off, typing in the fractions. To tell the calculator that it's a fraction, you should use parentheses around those. So I'm going to start with a parenthesis, 2. And then the best way to write the fraction is to use the fraction button. That's this ABC button right here. It has A and then B/C on it. And when you type it in, it looks like a backwards L. And then the 3 in parentheses. Minus, repeat that for the 1/6. 1 ABC 6 in parentheses. When you hit equals, it will spit out the fraction, 1/2. The other type I'll go a bit quicker because, like I said, the buttons are the same. The placement's just a little different. So other calculator, we have 2. And then again, ABC button, it's in the middle, 3 down. Looks the same. 2/3 minus 1/6. And it will give you the same answer, 1/2. And this is our answer, x to the 1/2. That stands for probability. We're actually going to use that next unit. Any questions over the problem, over the calculator? Yes. Yes. Is this, that looks the same from here. Is that this one? Yeah. Yeah, okay, go ahead.
Oh, I can do the fraction part.
What about it?
Like,
Are you talking about this right here?
yes.
ABC, it's under the PRB button. It's right here.
Oh, fine. Okay, thank you.
Yeah, you're welcome. Again, I'm going to, on the side, write the rule that we just used there. When you divide the same bases, subtract. The exponents. These next couple of problems are utilizing both of those rules, so we'll go through them. No new rules here. We have x to the 4/3 over x to the 1/6 times x to the 1/2. Hopefully you see what I see here. We should do the multiplication on the bottom first, and then we can divide. Dividing is much easier when you have one term on the top and the bottom. So for starters, I'll just bring over the x to the 4/3. On the bottom, we're multiplying the x's, so we'll add the exponents together. So 1/6 plus 1/2. Again, different denominators. This is when I would want to use the calculator. I'm only going to demonstrate with the white calculator this time, but there is a problem coming up where I'll use the pink. All right, in parentheses, we have 1/6. Use the ABC button in between. 1 ABC 6 plus, in parentheses, 1 ABC 2. Pops out a nice 2/3. And now we have the same denominator. So now we can actually divide, which again means we subtract the exponents. 4/3 minus 2/3. And again, since they have common denominator, I'm just going to do the subtraction. 4 minus 2 is 2. We end up with 2/3 as our final answer, final exponent. And there you have it. Questions over number 3. Close it, please. All the way. Thank you. Number 4. Same type of problem. A to the 3/2, A to the 1/2 over A. When you have two letters written, basically smashed together, what does that mean? Yes, multiplication. We do it with letters and we do it with numbers and letters together. You just write them side by side. The multiplication is what's implied here. So once again, we're going to add those fractions on top first and foremost. We have A to the 3/2 plus 1/2. Now on your own, if you don't want to necessarily write this out, like when you do your own work, you know you need to add the fractions, that's fine. I'm just doing this for notes purposes. Common denominator, so this one's going to be pretty nice. A on the bottom. On the top, we have 3 plus 1, that gives us 4/2. And since that divides nicely, I'll go one more step and turn that into a 2. And now we don't even have a fraction. On the bottom, acknowledge that this is A to the 1st. So we get A to the 2 minus 1. Dividing will subtract the exponents. And lastly, 2 minus 1 is just 1. This is A to the 1st. Or you can always drop the 1 and just say A. There you have it. Questions on number 4. Number 5, this is our next rule. X to the 2/3 squared. This is called a power to a power, where you have exponents together. This is when you are finally allowed to multiply. So let's do that. X to the 2/3 times 2. Again, I'll be putting this into the calculator, so if you'd like to turn that 2 into 2 over 1, you may, but there's really no point to it. So we have 2ABC3 in parentheses times 2 can stand alone, it doesn't need parentheses. This means 1 and 1/3, the mixed fraction. We don't use mixed fractions in here, we use improper. We just want a number over a number. So this is going to be its automatic result. You have to tell it that you want it the other way. To do that, you're going to use that ABC button again. Above it says D/C. That's the improper fraction form. So all I need to do is hit Shift ABC and it'll switch it to the other form. 4/3 is what I'm wanting here. I will demonstrate this on the pink calculator. Let me type this stuff in real quick. Or I guess I got a blue one this time. So the other calculator looks Same, but a little different. The button, again, you'll need what's above the ABC. It looks a tad different. It shows ABC, some arrows, and then DE. This is just a conversion button. So I'm going to hit second ABC, and again, on the screen, it's going to look a little different from the white calculator, but it's going to do the exact same thing. That's just telling the calculator to convert it, and then it pops out with a nice 4/3 again. So, same buttons, it just looks a little different. 4/3 is our answer here. And again, there was a rule here, so I'm going to write a couple notes on that. This one's called power of a power. When you have an exponent raised to another exponent multiply them. When you're ready, flip the paper over, please, so I can see who still needs to write and who's done. Next couple problems are just, again, practice with these rules. X to the 3/4 to the 2/3 times x to the 5/3. First, let's take care of this double exponent. This is where we multiply. So we have x to the 3/4 times 2/3. And then that'll be times x to the 5/3. I'll use my calculator to do that part for me. Three ABC4 times 2 ABC3. And it's just a simple 1/2 times x to the 5/3. From here, I got the same base. When I multiply, I actually add those fractions together. So now it's x to the 1/2 plus 5/3. Again, I'll use my calculator for that. 1 ABC2 plus 5 ABC3. And that gave me a mixed number, so I need to switch it to the other form. Shift ABC will do that. And I get 13/6. Now you have it. Questions on 6 before I move to 7. Seven is a unique problem. There are two ways you can go about it. You can do the division first, which if we follow order of operations, we would technically need to do that since it's inside the parentheses. do the division, and then whatever that answer is, you'd square it. Or there is a property, an exponent's property, we can use here to actually go in the opposite order. We can take care of the exponent first and then do the division. Since we're focusing on exponent properties today, that's the way I'm going to go. To show you properly, I'm going to write this out so I have a little bit more space to work with. So we have m to the 3/2 on top. Over on the bottom, you need to recognize that this is m to the first power. If you don't, that's where a potential mistake can be made. And it's that whole thing squared. As you can see, this is a power to a power problem, and we have two powers here, so we apply the rule twice to the top and the bottom. This is going to look a little wonky, but we multiply there, and we multiply here, so we're multiplying twice. Both of those get multiplied by 2. I'll write that out so it's a bit more clear. So it's m to the 3/2 times 2 and m to the 1 times 2. We do both of those. On the bottom, 1 times 2, clearly that's going to be 2. On the top, m to the 3/2 times 2, just to save us some time, I'll tell you, that gives you 3. So m cubed. And the fractions are now gone. Now we can divide. Dividing the bases, we subtract the exponents, m to the 3 minus 2, which gives us m to the first, or just m. I'm going to do 8 and 9, and then we'll cut the notes off there. We'll finish them up on Friday. 8 and 9 cover a kind of a new rule, if you will. Number 8, square root of x cubed over the cube root of x squared. I'm going to zoom in just a little bit here. We've already seen a problem like this. I gave you one just like it last week, probably a couple of them. When you were given this problem last week, what were you to write on the problem? Huh?
The answer.
And what is the answer? We have two different roots here. We have a square root and a cube root. You can't divide them. That is true when it's in radical form. But we now know how to write this in exponent form with the fractional exponents. You can do the math when it's written that way. We've been doing that on these notes. So that's what we're going to do first. So I can turn those into fractional exponents. And we talked about that last week as well. What was the rule here? What over what?
Outside on top, inside on bottom.
Flip it.
Bottom on top.
In over out. Inside over outside, in over out. So to turn this into a fraction, on the top it's 3/2. And then on the bottom it's 2/3. In over out. We'll use that rule quite a bit. When it looks like this, now we know how to do this. Again, we've been doing it. We can do it with our calculator. We're dividing, so we'll subtract those numbers. 3/2 minus 2/3. 3abc2 minus 2abc3, 5/6 if you type it incorrectly. While this is the answer, I am technically not done. Simplify each radical. We started with radicals, we need to end with radicals, so we need to put it back. Again, in over out. The 5 will go inside with the x, and the 6 will go outside as the index. That is my final answer there. Again, I'm going to make a note here explaining what I did. You can't do this in radical form. So put the terms in exponential form.
Let's start.
So when that happens, you come across a problem that you can't do in the radical form. You will switch it and do the math anyway. Number 9, this will be our last problem for today. Same concept here, except we're multiplying instead of dividing. We have a 5th root and a 7th root. Can't multiply when it looks like that, so let's change it. And just a warning, these numbers will get a little ridiculous. We have x to the 2/5 times x to the 3/7. Again, when we multiply the terms, we're adding the exponents. X to the 2/5 plus 3/7. We have 2abc5 plus 3abc7. 29 over 35. Reminder, we started with radicals, we end with radicals. As a fraction, I don't think it looks too bad, but it's going to look really ridiculous in the other form. In over out, 29 inside, 35 outside. You're not going to see anything that large on a quiz test, nothing like that. Probably not even in calculus, if I'm going to be honest. That's very rare, but a possibility nonetheless. This is our final answer. We'll do the negative exponents when I see you for the next class.